Welcome back, welcome back, welcome back. I'm Miss Lisa, and this is my YouTube channel where we talk about everything I want to, science and math. And we're doing physics, chapter 18, talking about mirrors. And there's a nice little picture of a rose in a mirror. You can see that it is a convex mirror because it looks bigger. So that's like a makeup mirror. All right, so what we're going to do now is the math. And this math, in a way, is very easy. So much that I didn't even do it out over to the side. All you do is that they'll give you everything in a formula that you need but one thing, and you solve for the other one. The only thing that makes it hard is their fractions, and there is a certain group of population that doesn't like fractions. But you don't have to worry about them. It's not hard like 6th grade because you're just going to plug it in your calculator, and your calculator is going to do the work, the hard fraction work for you. You don't have to worry about, you know what makes fractions hard is you have to have a like denominator and all that. Not here. Not for this, because we're just going to put it in our calculator. So here's our problem. An object 2 centimeters high is 30 centimeters from a concave mirror. The radius of curvature of the mirror is 20 centimeters. What is the location of the image? What's the size of the image? So those are our knowns, and here are our formulas we're going to use. 1 over f equals 1 over d sub I plus 1 over d sub o. Those are distances, and that's your focal thing. All right, so first we have to figure out what is f, and f equals 1/2 radius. So we put that in, our radius that they gave us, divide by 2, and we get 10 centimeters. Now they rearranged their equation. I don't. I would have just substituted it in and solved it, but you can do it however you want. If you like this way. The public school I teach at now, they teach the kids to do this in physics. And I'm just like, no, there's no reason to do that. But anyway, you substitute in everything they give you, and you're going to solve, first of all, for d sub I, the distance to the image, what it appears to be, and then m is we plug that in. You can rearrange it if you want and solve it. So you can do it my way, or you can do it this way and see if you get the same answer, okay? That's how all of these are going to go. Here's number 2. Find the location of the image in the figure they've got. If an object 2 centimeters in height is 5 centimeters in front of a concave mirror with a focal length of 10 centimeters, how large is the image? Those are our knowns and unknowns. Same basic equations here that we had before. We fill them in and get the answers. So give it all a try on your calculator. Number 3, calculate the position of the image in figure 1811. So that's over here. Here's our setup. Use the mirror equation. So there's our same equation one more time. They give us everything but d sub I. You plug it all in and solve for it. They rearrange, I wouldn't, but you do it however you want. Okay, and there's the lab. And see how they use a light, the glass, and the cardboard? What we did is we used the sun for the light. For the glass, we used the glass of a window and held the cardboard there, and we were able to see by turning our back and looking at the cardboard, we were able to see outside. So we did it that way, and it was pretty fun. Right there you can see the light being split. Okay, example problem 4. Look, same equation. So we plug it in. You know everything but one thing. You solve for the one thing you don't know. And this time it's d sub I. You're just doing the same problem over and over again. Look at this, number 5, same equation. You plug in everything you know. There'll be one thing you don't know. It's d sub I, and you solve it. So we do this same math in physical science. So this is really a little bit easier math. Like I said, the only thing that makes it hard is fractions. But they're not hard if you use your calculator. Come back, and we're going to talk about diffraction and interference of light, which is very interesting. Like, share, subscribe, and remember, science is great.